MCQ 15 is another reaction kinetics question. So investigating the question over here, it mentioned that the rates of chemical reactions can be increased by increasing the concentration of reactants. This we know for a fact because if the particular reactant is either a first order or a second order reactant, definitely its change can affect the rate as per the order of reactions that you're seeing. And the last portion here is going to be increasing temperature. Now, whenever we talk about temperature, it's important that we talk about your Maxwell-Boltzmann diagram. So in your Maxwell-Boltzmann diagram, it shows the general distribution of kinetic energy of particles in any form of reaction system. And unique to each reaction is actually its own activation energy. And only particles that possess energy that is more than its activation energy or equals to it can actually go for effective collision, and the magnitude of this shaded area over here represents the value of your rate constant. So if we are increasing the temperature, the graph itself will actually be shifted towards the right because the average amount of kinetic energy for all particles will actually increase. However, the peak of the graph must actually comes down a little bit because the particles did not change, so the area underneath the curve must have been the same. And now you can see that the new rate constant here, let's call this as K with the increment of temperature, is going to be of a much larger magnitude because it comprises of not just the orange but as well as the blue color shaded area. So another way that we can actually adjust the rate constant apart from using temperature is also to change with the usage of a catalyst. So a catalyst, what it does is that it brings down your activation energy. And by bringing down the activation energy, you can see that there's now additional shaded area to be seen. And this means that your rate constant is also increasing as well. So do take note that temperature and catalyst are the items that can affect your rate constant, but apart from that, changing your pressure, your concentration, as well as your exposed surface area has totally nothing to do with increasing your rate constant K. It does affect the frequency of effective collision, but it does not affect your rate constant K. So going through each of the statement here, in part 1, increasing the concentration increases rate constant. This is true. In part 2, increasing the concentration increases the proportion of particles having energy greater than activation. Now this can only be manipulated by using temperature or catalyst. So this is untrue again for option number 2. Number 3 here, increasing temperature increases the rate constant. Definitely a true part to this as explained by your Maxwell-Boltzmann diagram. And in number 4, increasing the temperature increases the proportion of particles with energy that is greater than the activation. This is definitely shown by the transformation of the curve towards the right side along the x-axis. So number 4 is correct as well. And this means that option D is the correct answer here.